Bismillahirrahmanirrahim. Assalamu alaikum. Today our topic is the second procedure through which we are checking the feasibility of aggregate. So that is the chemical analysis. Chemical analysis we are doing for two types of reaction. There are two types of reaction, and mainly we are calling this alkali aggregate reaction. If there is any reaction between the aggregates and the alkali from the cement, so it is called alkali aggregate reaction, or you can say AAR. And there are two types of reaction mainly. One is called ASR, alkali silica reaction. If there is any siliceous aggregate, it reacts with the alkali from the cement, so finally they are producing a product which is water loving, and it will absorb water, which will expand, and it will cause expansion, which is not suitable for concrete. And we are going to determine this alkali silica reaction through ASTM C289. And the other thing is like sometime we have this dolomitic limestone, where the de-dolomitization process create again a problem for some volume changes and cause expansion in the concrete. And we are going to check this chemical analysis through STM C586. So these are the two standards. If there is any issue with the siliceous aggregate are there, so we are going to use and check the ASR reaction, and the standard we have to use for this one is ASTM C289. And for if any alkali carbonate reaction is there, so that one we have to check with ASTM C586. In this chemical analysis, there is nothing involved for the concrete mix. This is directly we are checking the aggregate, or you can say the rock, directly. So what is the main procedure, what is the main calculation way how we are going to check this one? So in the ASTM C289, basically we are determining the two things. One is the dissolved silica, and which we are representing through SC, and the other is reduction in alkalinity. When we will get these two values, then there is a standard graph in this ASTM C289 standard. There we will plot our values, and then there are some zones where clearly mentioned that whether in this zone is an aqueous material, the other is potential deleterious, and some is considered deleterious. So after all this calculation and plotting it on the graph, if any material is coming under the innocuous material, so it is safe and easily you can use this one. There is no fear for expansion or for anything. But if it is coming under considered deleterious material or potential deleterious material, then of course we have to go for further testing, and we have to calculate the limit of expansion, whether this one is under acceptable limit or not. So we have to check this one further. First we did the petrography. If there is any deleterious material, we are going to check the chemical analysis, and after chemical analysis we have to do further testing for the concrete. The other method is for alkali carbonate reaction, which I mentioned earlier, is the ASTM C586. This is the standard. In this one, what we are going to do, we are going to prepare some rock cylinders. These rock cylinders are the length should be 35 plus minus 5 mm, and the diameter must be 9 plus minus 1 mm. We are preparing these rock cylinders, then we are putting them in the sodium hydroxide solution. In the sodium hydroxide solution, we will keep it there as per the specified time of this ACMC 586 standard, and we will take reading for 7, 14 days, 28 days, and at 4 weeks. After calculating this one, we will consider any rock is deleterious or it is feasible. So what is the basic criteria for this one? After 28 days, we will check the length, the diameter, the dimensions, and any rock aggregate will be considered as deleterious if expansion 0.10 or more at 28 days age we are getting. Like any rock cylinder where the expansion is more than 0.1% at 28 days age, so it will be considered as deleterious rock. So thank you for today, and The third one we will go for the motor bar method. In the next video inshallah we will discuss about that one.